Hey guys, I was a day up here. So lesson 4 in chapter 5, we are adding on to our triangles and angles. We know from review for lesson 3 that we talked about triangles have 180 degrees when we add all three angles up, no matter what. And we're going to find out that there's a rule that we can follow to find the degrees of all the angles of any polygon. Remember, polygon is a generic term. They're all polygons, and then each one has a different name: a triangle, a quadrilateral, a pentagon is 5, a hexagon is 6, heptagon is 7, octagon is 8, nonagon is 9, and decagon is 10. So we're going to review some of those with these questions, and if you're not sure, I do have them written on the board in the classroom as well. Okay, so polygon, here's a word that is on your vocab sheet. You may want to add a simple closed figure. It's formed by 3 or more line segments. So 3 is a triangle, and you keep adding more, the name changes. These segments only intersect at their endpoints. Okay, in order to find the sum of all the angles in a polygon, you simply use this formula. And that formula derives from, I'm going to go down to slide 3 right here. So we know in a triangle it's 180 degrees. All right, what's cool is if we have a quadrilateral, I can draw one diagonal, creating 2 triangles, and 2 times 180 is 360. A pentagon, 5 sides. Ooh, if I could spell pentagon, hexagon, quadrilateral. Okay, pentagon has 5 sides, and notice if I draw all the diagonals from one vertex, I create 3 triangles. So 180 times 3 is 540. The hexagon, I can create 4 triangles from one vertex. So 180 times 4 is 720. So if you'll notice here, the number of triangles compared to the number of sides is always 2 less. That is where we get this formula. It is the number of sides subtract 2 times 180, because the number of sides minus 2 gives us how many triangles there are. So number of sides minus 2 times 180. A couple things here. Important terms is that if something is equal angular, seems pretty obvious, but all angles are equal. Equal angular also means usually that equilateral, all sides are equal. If all sides are equal, all angles are equal as well. If all sides and all angles are equal, then it is a regular polygon. So when I use the term regular, or when your worksheets or your book uses the term regular, you can assume all angles are congruent and all sides are congruent. All right, so right here, sliding down, we're going to use this formula to find the sum of the measures of the interior angles. That means all of them added together. Of a decagon has 10 sides, so there's a key. So it is going to be the sum equals 10 minus 2 times 180. I'm pretty sure I know this, but I'm double checking because I don't want to be wrong. So it is 1,440 degrees. It is that simple. Okay, hexagon, that's 6 sides. So 6 minus 2 times 180. And we did that actually just to the, if you slide over right here, is that one. It is 720 degrees. An octagon is 8 sides, so the sum is 8 minus 2 times 180 degrees, or 6 times 180, and we get 1,080 degrees. Now this is all of them added together, and so obviously the more sides we have, 15 minus 2 times 180, the more degrees we have when we add them all together. So 13 times 180 will give us 2,340 degrees. Obviously, a 15 gon has 15 sides. I didn't have to hint at that. Okay, that is the formula to find the sum, all of the angles added together. Now remember, if you have 10 sides, you've got 10 angles. If you got 6 sides, you got 6 angles. 8 sides, 8 angles, and so on and so forth. So let's turn that over and let's add on to this. All right, once we find the sum of all the angles, if it's a regular polygon, we can use it to find one angle inside because they're all the same. So you find the sum using the n minus 2 times 180, and then after you find that sum, you divide by the number of sides because the number of sides is the same as the number of angles. So the formula actually looks like this. One angle in a regular polygon is found by taking that sum formula and then dividing by n, which is dividing by the number of sides. So take a look at this example. We've got a chamber and a honeybee comb, and a bee honeycomb is a regular hexagon. Notice the word regular hexagon. That means all sides are equal, all angles are equal. Find the measure of an interior angle, one angle of a regular hexagon. So first we're going to start out with the 6 minus 2 times 180 degrees. Okay, and we're going to take that sum and divide it by 6. So we get 720, and when we divide that by 6, we get 120 degrees. All right, so we take the sum and divide it by the number of sides, as long as it is regular, because if it's regular, they're all equal. So let's do that a couple more times. An octagon, hopefully you remember octagon has 8. So one angle, we find the 8 minus 2 times 180, and then to find one angle, we divide by 8. So if I look on the back side, that octagon was, I don't even have to calculate it out, it was 1,080, and when we divide that by 8, we get 135 degrees. Okay, a heptagon, there's a new one, is 7. Hep is 7. Don't really have any easy way to remember that except it's goofy. So 7 minus 2 times 180, and then we will divide that by 7. So we get 900, and when we divide that by 7, if you guys are doing this with me, you're going to get a decimal. It's an ugly one. That's why it says to the nearest tenth. So 128.6 degrees. And then a 20 gon. Now this is ugly. We got 20 minus 2 times 180 divided by 20. So 20 minus 2 times 180, we get 3240. And then we have to divide that by 20. It'll go in there nicely. Take a look at that, 162 degree angles. Each angle in a 20 gon is 162 angles, because the more sides we add, the bigger that angle becomes. Okay, eventually when you get an infinite number of sides, what happens? It gets very, very close to a circle. Okay, let's slide down here. What if I give you the angle measure and want you to find the number of sides? Okay, you can do this backwards. All right, we can also find the number of sides of a regular polygon when given the sum or when giving one angle. Okay, obviously if they give you one angle, it's a little bit harder. We work the formulas. It is n minus 2 times 180. Oh, sorry, we work the formulas backwards. We work them backwards. So if the sum of the interior angles, that is n minus 2 times 180 degrees, is 2160. we are going to work backwards. I'm going to show you two ways to do this. The first way is, in my opinion, the easiest way. Think about the last thing we do. If we do it backwards, we're going to divide by 180. Okay, so 2160 divided by 180 is 12. So n minus 2 is 12. So the last step would be to add 2, working it backwards. There are 14 sides. Now, I could have also done this a little bit more algebraically. If I have n minus 2 times 180 equals 2160, I could have decided to distribute that 180 first, and then minus 2 times 180 is, n, 360 equals 2160. I then add 360. I'm running out of room. 2160 plus 360 is, I'm going to slide her down here, 2520, and I have 180n equals 2520. So then divided by 180. We could do it either way. This way is actually adding a step, and we better yet, I do 14 sides. I'm adding a step because first I'm distributing, then I'm adding 360, then I'm dividing by 180. If we do it this way, divide by 180, add 2. It's a little bit quicker, but you can get it the same way. All right, what if they just give us one angle and they tell us it's irregular? Okay, well, again, couple ways you could do this. One angle is found by taking n minus 2 times 180 and dividing by n. That's how we get 160. Okay? Now, you could just start plugging numbers in until you found out what 160 get, how you get 160. You know that the number of sides has to be on a positive integer, and you could just keep plugging them in. Or you could solve it algebraically. How do we do this? Well, right here's the steps. 1, get rid of the n in the bottom. So we're going to take both sides times n. When I do that, that cancels. I don't actually distribute the n to anything on top. I simply cancel the denominator. So now I have n minus 2 times 180 equals 160n. Now, as it says in number 2, distribute. So now I'm going to take that 180 and distribute it. So 180n minus 2 times 180, which is 360, equals 160n. Now we just solve it. That's algebra. We did that last year, before Christmas. Okay, so combine your terms. Notice we have an n on either side. I'm not going to move this one because there'd be nothing left. So I'm going to subtract 180n. I drop down my minus 360, don't forget the minus sign, and I actually get a negative 20, which some of you might be panicking, but what happens when they're both negative? And I divide by negative 20, it becomes positive. And 360 divided by 20 gives me 18 sides. So we can use both the formula with a regular polygon and a single angle, or the sum to work backwards and find the number of sides. All right, there is one last thing in this lesson which looks really goofy, but it's easy. It's the easiest thing we're going to do, and that's exterior angles. We talked about exterior angles of triangles. This one is exterior angles of any polygon. The cool part of this is that no matter how many sides, this picture gives us not only a pentagon, but a regular pentagon. Okay, when you extend all of the sides to create exterior angles, when we add all 5 of those angles up, it will always equal 360. That's not just for a pentagon, it's for triangles, it's for quadrilaterals, it's for hexagons. It works that way because remember, the more sides we have, the bigger angle we get on the inside. If the inside angle is bigger, what happens to the outside angle? It gets smaller. So exterior angles will always, no matter how many numbers of sides, will always add up to 360 degrees. Okay, so these are really simple. If they're always going to add up to 360 degrees, if I have a regular hexagon, that means I got 6 sides, 6 angles, all equal because it's a regular. Well, those outside angles, exterior angles, are all going to be the same. So guess what? It is 6 times some amount has to equal 360 degrees. In other words, divide by 6. And it's 60 degrees. Same thing, triangle. How many sides? 3. So I have 3 angles. 3 angles, all at the same size, must equal 360 degrees. So when I divide by 3, you get 120. A quadrilateral, 4. So 4 times some amount has to equal 360. Well, if it's a regular quadrilateral, folks, it's a square. If the inside angle is 90, so is the outside angle. An octagon, 8 sides. So 8 exterior angles, all of them equal 360. And when we divide by 8, the number of sides is, the number degree angle will be 45 degrees. All right? Because this is so simple, number of sides times exterior times the number of angles, which is the number of sides, times what each measure equals, because they're regular, has to equal 360. I can use that equation to solve it for the opposite one. What if they give me the angle instead of the number of sides and ask me for the number of sides? Well, it was the number of sides, or the number of angles, times 22.5, because they're all equal, has to equal 360. And so how do we solve that? We divide 360 by 22.5. So it doesn't matter what you're finding, you take 360 and divide by the one they give you. If they give you the sides, you divide by the number of sides, find the angle. If they give you the angle, you divide by the angle and find the number of sides. So in this case, 16 sides. All right? You have a couple worksheets, so good luck with that, and make sure you come and see me if you have any questions.